Could all the water on Earth put out the sun, every ocean, every glacier, every cloud, every drop you have ever touched, gathered into a single impossible sphere, a floating blue world, larn 300 kilometers wide, suspended in silence? Now let it fall. Straight into our star. You expect steam, a dimming sky, relief for an overheating planet. But the sun is not a campfire. It does not burn the way your instincts tell you it should. It runs on gravity, on pressure, on nuclear fusion. In exactly 8 minutes and 20 seconds, darkness will not arrive. Light will. Because in the cold mathematics of the cosmos, water does not extinguish stars. It feeds them. So the real question isn't whether the sun survives. It's what breaks first, the star or the world that tried to save itself. This is the ultimate thought experiment, not designed to comfort, but to reveal how the universe actually behaves. Before this scenario is pushed to cosmic extremes, one rule must be clear. What follows begins inside real physics until it is deliberately scaled beyond it, to explore what the universe could do, not just what it would do. Intuition tells you that 1.4 quintillion tons of water should extinguish anything. On Earth, water kills fire by stealing heat and choking oxygen. But the sun is not a fire. It is a nuclear fusion engine bound by gravity so extreme that mass itself becomes destiny. When you pour an ocean into a star, you are not fighting heat. You are feeding gravity. You are giving fuel to the very force you hope to stop. So let's begin. Drain the oceans, strip Earth to bare stone, and find out what truly happens when we try to drown a star. So how do you drown a star before anything burns, before anything changes? You must answer a far more brutal question. How do you even get the water there? You might think the sun is the ultimate cosmic garbage disposal. It dominates the solar system, hoarding 99.8% of its total mass. Intuition tells you its gravity is inescapable, that if you simply push something off Earth, it should fall straight down into the fire like a stone dropped into a well. That intuition is wrong. In orbital mechanics, gravity is only half the story. The other half is motion. The sun is not a vacuum cleaner pulling things inward. It is an anchor swinging everything around it. Earth, the oceans, and everything you know are not hovering. We are moving fast. This is the first trap, the gravity trap. We are not protected from the sun because it is far away. We are protected because we are moving sideways at extraordinary speed. To drown the sun with our oceans, we must first defeat the very motion that keeps our planet alive. We must fight gravity's river, and the current is far faster than it looks. Right now, you feel motionless. But relative to the sun, you and every ocean on Earth are screaming through space at 30 kilometers per second, 107,000 kilometers per hour. This sideways speed is the only reason Earth does not fall into the star. We are in constant freefall, but we miss the ground every time. That is what an orbit really is, a perpetual miss. This is why drowning the sun is so difficult. If we simply launch our massive sphere of water toward the sun, it carries Earth's sideways momentum with it. It does not fall in. It curves, swings wide, and misses settling into a new orbit as a wet, useless planetoid circling the star. To hit the sun, we must do something far more extreme. We must erase that sideways motion. We must cancel 30 kilometers per second of velocity and bring the ocean to a dead stop relative to the sun. Only then can gravity finally pull it straight down. Humanity has done this once on a tiny scale. The Parker Solar Probe, the fastest object ever built, was not fired at the sun. That was impossible. Instead, it performed a 7-year gravitational ballet, stealing momentum from Venus again and again, inching closer with every pass. 7 years for a machine the size of a car. We are trying to move 1.4 quintillion tons of water. We cannot dance with gravity. We must overpower it. This is the delta V wall. From low Earth orbit, stopping the oceans would require roughly 24 kilometers per second of velocity change. Compare that to the 3.6 kilometers per second needed to reach Mars. We are attempting the most energy-expensive maneuver in the solar system, with the heaviest payload imaginable. Picture a Formula One car racing at 300 kilometers per hour. You want to drop a rock so it lands on the hubcap of your own wheel. If you simply release it, the rock moves forward with you. To make it hit the wheel, you must throw it backward at exactly the same speed, canceling all motion, before gravity can pull it down. Now imagine the rock is the Pacific Ocean, and the car is the Earth. Chemical rockets are useless here. The Tsiolkovsky rocket equation is a cruel mistress. To launch the oceans using conventional fuel, we would need a fuel tank larger than the universe itself. The math simply doesn't allow it. To execute this sacrifice, we must turn to mega engineering. We would need to construct a planetary network of mass drivers, gigantic magnetic coil guns, wrapping around the Earth's equator. These aren't launch pads, they are cannons. We load the water into containment pods. We align the cannons to fire retrograde, directly opposite Earth's orbital motion around the Sun. We treat our oceans as ammunition in a war against our own momentum. As the cannons fire, they accelerate the water to 30 kilometers per second in the opposite direction. The recoil would be catastrophic. The energy demands would hollow out our civilization. But on paper, cold, indifferent paper, it works. As the water leaves the barrel, its orbital velocity relative to the Sun drops to zero. For a brief moment, the giant blue sphere hangs motionless in the void, stripped of the lateral speed that acted as its shield for 4 billion years. Then the slide begins. The Sun's gravity, ignored for so long, finally claims its prize. The water begins the long, silent plunge across 150 million kilometers of vacuum. It will take months to fall, accelerating, constantly transforming from a static sphere into a hypervelocity impactor. We have successfully engineered the delivery. We have overcome the gravity trap. The water is on its way to the fire. But the cost of slowing down Earth's motion is not paid in space. It is paid below, right beneath our feet. As the last payload canisters vanish into the upper atmosphere, propelled by the violent magnetic pulse of the orbit killing machine, the cost finally arrives beneath our feet, and a strange silence descends upon the world. The recoil tremors have stopped. The roar of the mass drivers has faded. Now the survivors emerge from their bunkers to witness a sight no human civilization was designed to process. The oceans are gone. We aren't talking about a low tide. We are talking about the total excision of the hydrosphere. Where the Pacific Ocean once stretched to the horizon, there is now only a jagged gray abyss plummeting 4 kilometers down. The continental shelves, once teeming with life, are now vast salt-crusted cliffs overlooking the empty basins. The blue marble has turned brown and gray. From space, the Earth looks diseased, its vibrant skin peeled away to reveal the rocky muscle beneath. The Marianas Trench is no longer a dark mystery. It is a gaping canyon, a scar cut deep into the crust, exposed to the thin, desiccated air. The majestic coral reefs are now bleaching skeletons, baking in the sun. The silence is absolute. There are no waves to crash against the shore. There is no rain to patter on the roof. The rhythmic heartbeat of the planet, the sound of water, has stopped. But the Earth does not remain silent for long. Silence was only the intake of breath. We often forget that water is heavy, incredibly heavy. The oceans exerted an almost unimaginable weight on the ocean floor. For billions of years, this weight pinned the tectonic plates down, keeping the planet's geology in a tense, pressurized balance. We just removed that weight in a matter of days. The result is a phenomenon geologists call isostatic rebound, but on a scale that defies modeling. The planet's crust begins to spring back like a mattress when a sleeper stands up. But rock is not memory foam. It is brittle. The sudden relief of pressure triggers what can only be described as a planetary unburdening. The ocean floors heave upward, shattering the tectonic locks. Super earthquakes, far exceeding magnitude 9.0, rip through the ring of fire. Dormant volcanoes, their magma chambers suddenly depressurized, erupt in unison, spewing ash columns that reach the stratosphere. The continents themselves groan as they settle into new equilibrium positions. Cities that survived the initial construction of the launch infrastructure now crumble as the very ground beneath them ripples like a storm-tossed sea, a cruel irony for a world that has lost its water. We didn't just dry out the planet, we broke its back. Amidst the quaking ground and the choking ash, the few remaining humans realize that the temperature is changing, and it is changing fast. Water vapor was our dominant greenhouse feedback, a thermal blanket that trapped heat and kept our nights warm. The oceans were our thermal flywheel, absorbing the sun's rage by day and releasing it by night. Without them, the Earth loses its ability to regulate its own fever. Welcome to the desiccated world. During the day, without clouds to reflect sunlight, the solar radiation strikes the surface with unfiltered malice. Temperatures soar past 100 degrees Celsius in the equatorial basins. The sky, stripped of the moisture that scatters blue light, turns a sickly, pale white. A blinding cataract eye staring down at the ruins. But when the sun sets, the horror truly begins. With a thinned, desiccated atmosphere unable to hold heat, the temperature plummets instantly, dropping to minus 100 degrees Celsius within hours. We have turned Earth into a chaotic twin of Mars. The planet is racked by supersonic winds, driven by these extreme thermal gradients, kicking up storms of salt and toxic dust that scour the landscape. Civilization is huddled in the dark, freezing and burning in turns, gasping for air that is too dry to breathe. We have sacrificed our home to save the solar system. We have turned the cradle of life into a silent tomb. And while the Earth gasps its last breath, the missing water, that massive, shimmering sphere of hope, is accelerating through the void, preparing to unlock the next tragedy deep inside the heart of the sun. While Earth is dying in silence, the cause of its death, that massive, glistening sphere of stolen water, is approaching the end of its journey. It has fallen for months, accelerating under the sun's immense pull, reaching speeds of over 600 kilometers per second. Intuition suggests a splash. We imagine a colossal hiss of steam, like pouring a bucket of water onto a bonfire. But the sun does not have a surface you can splash against. Before the water can even reach the photosphere, the visible surface of the star, it hits an invisible tidal boundary, often described as the Roche limit. At this precise distance, the tidal forces of the sun become stronger than the gravity holding the water sphere together. In an instant, the jewel of Earth is ripped apart. It doesn't break into drops. It is torn apart at the molecular level. The sphere disintegrates into a spiraling ring of superheated gas wrapping around the star's equator like a shroud. Then comes the heat. As this ring plunges into the solar corona, temperatures skyrocket to millions of degrees. The concept of liquid or steam ceases to exist. The electrons are stripped from their atoms. The water is no longer water. It has been flayed down to its subatomic soul, a chaotic plasma of bare nuclei plunging into the inferno. There is no hiss. There's only the silent scream of ionization. Deep inside the star, the physics of our mistake begins to unfold. On Earth, water extinguishes fire because the heat energy is used up, breaking the chemical bonds of the water molecule and turning liquid into gas. It starves the fire of heat and oxygen. But inside, a star breaking bonds isn't a cost. It's a prelude to disaster. The intense radiation drives a violent dissociation, ripping oxygen and hydrogen apart at the atomic level. The oxygen and hydrogen atoms are violently separated, and here lies the trap. By delivering water, we have essentially delivered a care package of refined rocket fuel to a nuclear reactor. The sun burns by fusing hydrogen into helium via the proton-proton chain. Hydrogen is its food. By stripping Earth of its oceans, we injected an additional 1.5 times 10 to the 20th kilograms of fresh hydrogen into the stellar core, insignificant by stellar standards, but not meaningless. We haven't dampened the reaction, we have stoked it. The fusion rate doesn't drop, it shifts upward. The core, sensing the influx of new fuel and the increased mass pressing down from above, responds the only way it knows: how it burns faster. We treated the sun like a campfire, forgetting that gravity turns everything you feed it into energy. But the hydrogen is only half the problem. The real killer is the oxygen. In stellar physics, elements heavier than helium are called metals, and they govern a property called opacity. Think of opacity as the thickness of the fog that light must travel through to escape the core. Oxygen is highly opaque under stellar conditions. It acts like a thermal blanket thrown over the fusion core. In reality, Earth's oxygen is far too little to matter, so in this amplified scenario, we imagine the amount scaled to stellar relevance. According to Kramer's opacity relations, increasing the star's metallicity through oxygen enrichment traps radiation inside, the energy generated by fusion struggles to escape. The pressure inside the star builds up violently. To handle this trapped energy without exploding, the star must expand. The consequences follow from stellar equilibrium and the Stefan-Boltzmann relation. As the star swells, its luminosity rises steeply with mass roughly proportional to the cube of its mass. The sun stops being our familiar stable yellow dwarf. From the ruins of Earth, the survivors looking up through their protective goggles would see a terrifying transformation. The sun is no longer yellow. It is bloating, expanding outward, and shifting its spectrum toward the ultraviolet. It turns a blinding, angry, electric blue. It has become something resembling a blue giant, hotter, brighter, and far more volatile. We tried to cool it down. Instead, we choked it with a thermal blanket until it feverishly evolved into a monster. And if a single drop of error, just the Earth's water, changed the star this much? What happens if we multiply that mistake not by 1 but by 1,000,000? The blue giant burning where our sun used to be is a terrifying sight, but it remains for the moment technically stable. We have ruined the solar system, sterilized the Earth, and altered the stellar lifespan, but we haven't destroyed the star itself. Not yet. To truly test the limits of physics, we must stop thinking like planetary engineers and start thinking like gods. On this scale, Earth's water was little more than a rounding error. To force a terminal conclusion, we need to escalate the input. And so, we invoke the final stage of our thought experiment. We conjure by pure assumption a sphere of water, not the size of Earth, but the size of the sun itself. Imagine a second star appearing in the void, a liquid star shimmering and dark, possessing a mass roughly equal to the sun itself. We are no longer just adding fuel, we are doubling the mass of the entire system in a heartbeat. As this liquid titan descends, the gravitational, intricate dance of the solar system shatters. The orbits of Jupiter and Saturn are yanked violently out of alignment. Then the merger begins. The water sphere doesn't orbit it, collides head-on. It's the ultimate cosmic car crash. Two objects each carrying roughly a solar mass about 2 times 10 to the 30th kilograms slam together. The kinetic energy of the impact alone would briefly rival the luminosity of an entire galaxy. But the real horror is happening deep inside, where gravity wakes from its slumber to claim its final victory. A star is a living contradiction, a delicate truce between two opposing forces. Gravity wants to crush the star inward, so fusion energy wants to blow it outward. This balance is called hydrostatic equilibrium. When we dump by pure assumption a sun's worth of water onto the sun, we break this truce instantly. We have doubled the gravity pushing inward, but the fusion engine cannot double its output fast enough to push back. The star's internal pressure structure fails. The pillars of hydrostatic support snap. Gravity wins. The entire outer envelope of the star, a mix of hydrogen, helium, and our superheated oxygen, begins to freefall toward the center. It isn't drifting. It is crashing inward at tens of thousands of kilometers per second, approaching a significant fraction of the speed of light. Inside the core, the conditions become hellish. The density skyrockets. The oxygen we introduced acts as a nuclear poison, increasing the opacity and trapping the heat until the temperature hits billions of degrees. The core is pushed past the point of no return into a regime that mimics the internal conditions of a core collapse supernova, even though the star itself was never meant to die this way. In the deepest regions, protons and electrons are squeezed toward neutronization, releasing a flood of ghost particles called neutrinos. This is the silent alarm. The neutrinos flee the core, passing through the collapsing layers of water and plasma, without touching them, screaming into the void that the end has begun. But for the rest of the matter, there is nowhere to go but down, slamming into the neutronized core with the force of 1 trillion nuclear warheads. The infalling matter slams into an ultra-dense, partially neutronized core and rebounds. The bounce creates a shock wave that stalls for a millisecond, then reignites, powered by the trapped heat and the screaming neutrinos. The star explodes. This is not a solar flare. This is something that resembles a Type II supernova in violence, if not in origin. A blinding flash of X-rays and gamma rays punches through the surface, briefly rivaling the combined brightness of billions of suns. The energy released in this single moment rivals a significant fraction of what the sun has produced over its entire lifetime. The shockwave expands outward at tens of thousands of kilometers per second. It does not burn the Earth, it erases it. There is no time for the atmosphere to ignite. There is no time for the mountains to melt. One moment, the desiccated, salt-crusted ruin of Earth is floating in space. The next moment, it is simply gone. The atomic bonds holding the planet together are shattered by the sheer intensity of the radiation front. The rock, the ruins of our cities. The dry ocean beds, they are instantly sublimated into a cloud of iron and silicon gas, joining the expanding debris field. This is the loss of memory. The explosion is so violent that it destroys not just the biology, but the geology. It wipes away the fossil record, the footprints on the moon, and the satellites in orbit. We wanted to see if water could kill a star. Instead, we turned the star into a bomb that scrubbed the universe clean of our existence. After the blinding violence of the terminal shock, a strange calm returns to the void. The screaming of atoms fades. Heat bleeds away into the endless cold of space. Where our solar system once spun a precise clockwork of planets and moons, there is now only an expanding cloud of gas, a nebula of haunting beauty glowing with hydrogen helium and an unusually high concentration of oxygen. To a distant observer, it would look like a flower blooming in the dark. They would admire its blues and reds, unaware of the story woven into its light. They would not know that the oxygen once filled Earth's oceans, or that the drifting dust was once cities' mountains and the bones of a civilization that challenged a star. We have achieved a kind of immortality, not by surviving, but by dissolving. We are stardust again, scattered across light years, waiting to form worlds that will never know our name. This thought experiment began with a simple, arrogant assumption that a star could be tamed like a campfire. That water by its nature must always cool, must always give life. But the universe does not deal in absolutes, it deals in context. In Earth's gentle atmosphere, water is a cradle for biology. In the crushing gravity of a star, that same water becomes fuel for a furnace. We learned that intuition fails at cosmic scales, that every solution carries a cost often paid in energy and annihilation. And we learned the universe's final rule: it is neither hostile nor kind. It is indifferent. It will take your greatest gift, your oceans, your lifeblood, and turn it into your undoing if the math demands it. In the end, the equation is simple. Water gives life. Gravity decides how it ends. The universe is not cruel, it is precise. And in that precision lie both every disaster we fear and every wonder we dare to explore.